All right, hello AB and regular calculus. Today we are looking at lesson 4.5, concavity and points of inflection, the second derivative test for relative extrema. Okay, so these two pictures that you see on your notes here, what you should notice about this is this first one, this is concave up, right? So it would have a positive second derivative. That's what this is saying. Okay, this is saying f double prime is positive. And for this one down here, this would be concave down, and it would have its f double prime, its second derivative would be less than 0. The thing to notice, and what we're going to be talking about today, the second derivative test for relative extrema. When I'm concave up, this critical number here is a relative minimum. And when I am concave down, if my second derivative is negative, I'm going to have a relative maximum. All right. They do have like a little nice memory device there for you. But let's go ahead and let's dive into this first example. We're given a graph to the right, and we're going to use those to answer these questions. For this first part, it says, on which intervals is the graph concave upward? Well, okay, so it looks like I'm going to be concave up through this portion right here, about halfway through. And then looks like my concavity flips right about here, so I'll be concave up again there. And I'm concave up here as well. So it looks like I'm coming from -2 all the way up to, I'm just going to call that -0.5. And then I'm going to have something like 1 to 2. And then for my last piece, I should be concave up from 4 to 5. On which intervals are we concave down? It looks like we're concave down from negative, and I'll do this in green. We're concave down on this interval from -0.5 up to 1. And then I'm concave down as well from 5 to 6. Notice how I didn't call out any concavity. This last, the section that doesn't have concavity, that's a straight line. I didn't make that concave up or concave down. This segment from 3 to 4 has no concavity, and I'll do this in purple. So this segment right here from 3 to 4, since that's a straight line, has no concavity. Then it asks for points of inflection. Our points of inflection are going to be where, this is where concavity changes. So my concavity, and really what we need is we need a positive to a negative, or a negative to a positive change in concavity. So we've got a POI at x is equal to 0.5, negative 0.5 rather, 1, and 5. All right, example 5, determine the points of inflection, discuss the concavity for the graph. So what we're going to do here is we're going to go f double prime of x, we're going to set it equal to 0, we're going to do a number line, and we're going to look for sign change. So my first derivative here, 4x cubed plus 3x squared minus 6x. Second derivative here, 12x squared plus 6x minus 6. To solve this for 0, I'm going to take out what I can. Looks like a 6. Oh, should be 2x squared. 2x squared plus x minus 1. And if I wanted to factor that, This is going to factor into something like 2x. I'm going to have a 1 in there, and then I'm going to have an x, and I'm going to have a 1. Now to get my signs to work, I need my positives to win, so the plus times 2x, that needs to be positive, and this is going to be 2x minus 1. So I'm going to have two numbers on my number line. If I set this equal to 0, my x values here would be 1/2 and -1. So I'm going to put a -1 on here and a positive 1/2. And now I'm going to plug in numbers around this into my second derivative. So if I were to plug in something less than -1, say something like -2, if I plug -2 into this, I'm going to get a negative times a negative, and that would come out to be a positive. If I were to plug in something between -1 and 1/2, 0 is going to be great here. I'm going to get a negative times a positive. That's going to come out to be negative. And after 1/2, I'm going to be plugging in something like 1 would be great, and I'll get a positive times a positive. And so what we see here is we need our points of inflection. So our points of inflection, we know that our x value is going to be -1 and 1/2. To find the values, I would plug into my function. My -1 isn't so bad. I'm trying to bring my calculator onto the screen. So my -1 isn't so bad. -1 up to the 4th plus, make sure to put your negatives inside parentheses, or else your calculator won't process that negative with the exponent. All right, we get -2 there. And I'm just going to hit second entry, and that will bring my function right back up. And I'm going to use this, and I'm going to type in my 1/2 now. So I'm using my delete button to get rid of my negative. And that should be that. And we get 0.4375. And those would be my points of inflection. Okay, let's go on to the second derivative test for relative extrema, and let's look at example 7. It says use the second derivative test to find the relative min and relative maximum points for the graph given. Right. So what we're going to do here is we're going to take our f prime of x, and I'm going to factor this a little bit. Now I can just go to my second derivative since I'm going to need that. But I do want to factor this one up here. I'm going to take out -12x from both, and I will get x squared minus 1 on the inside. So we are going to be setting that equal to 0, and we do see that we've got some critical numbers here. Our critical numbers are going to be a 0, and then a positive and -1. From our f double prime of x, now I'm going to set this equal to 0, and I'm going to solve this. So if I do that, I'm going to get x squared is equal to, it's going to be -12 divided by a -36. So I'm going to have this equal to 1/3. I'm going to have to take the square root of that, so x is going to be equal to plus or minus the square root of 1/3. And these would be my POIs. Now I shouldn't need those. For this, really what's going to be of interest here is using our critical numbers to figure out if they're relative mins or relative maximums. So I'm going to do f double prime of -1, f double prime of 0, and f double prime of 1. Now if I do f double prime of -1 and I plug the -1 in here, I am going to get out a negative number. With 0, I will get a positive number, and with 1, again, I will get a negative number. So this suggests if I have a negative number, this will be a relative max, and my 0 is going to be a relative minimum. So the points on that, this would be -1, 0, and 1. And to find the points, I'm just going to plug these back into my original equation. And if I do that, I'll get something like -3 plus 6, so that'd be 3. If I plug in 0, I'm getting 0. And if I plug in 1, I'll get -3 plus 6, which is 3. And that is example 7.